Consider the trial of tossing a coin twice. Let A be the event of at least one tail, B the event of either two heads and two tails, and C be the event of the first toss is a head. First question, list the sample space and the set of outcomes in each of A, B, and C. It's a bit of a tongue twister here. List first of all the sample space. Okay, so if I look at the sample space, so sample space equals, what I can have is I can have head, head, I can have head, tail, I can have tail, head, and I can have tail, tail. So that's the sample space. In the event of the outcomes, so if we look at the outcomes, they say let A be the event of at least one tail. So A, at least one tail, which means that will include everything that, so that's at least one tail, that's one at least one tail, and that one is at least one tail. So it means head, tail, tail, heads, tail, tail. For B, they say the event of either two heads or two tails. So two heads or two tails, that is the one that you're going to use. Two heads, two tails. In C, and C be the event that the first toss is a head. So the only one, this one and this one is the first head, toss is a head. So this is going to be heads, heads, or heads, tails. So that is A done. All right, in B they ask us, test whether A and B are independent. Okay, so remember what the test of independency is. Test of independency says that the probability for A and B, if that equals the probability of A multiplied by probability of B, then, so this is not a rule, this is a test. Okay, so if this is true, they are independent. So let's go and have a look at what's the probability of A and B, and I'm going to use my highlighter to explain this one. For A and B, so we are looking at A and B, and we see which one is and there. So which one is in both of those? And the only one that we have in both A and B, that tails is the same, and that's the only one that's in both of that. That's in that one and in that one. Okay, so the probability of getting tail and tail is going back to my original, to this one, we can say is 1 in 4. Okay, the probability of A times the probability of B equals the probability of getting A, we can see is, so the probability for A, let me just use another color. The probability of A will be 3 out of 4 because there's 3 possible things that can happen. So it's 3 out of 4. Multiply the probability of B, and the probability of B is 2 out of 4. And if I simplify 3 over 4 times 2 over 4, my answer is 3 over 8. Okay, so in this case we can see that left-hand side does not equal right-hand side, therefore they are not independent. They are not independent. They are not independent. Okay, and question number C. Just going to make it a little bit big again. They ask us, test whether B and C are independent. For B and C to be independent, the probability of B and C must equal the probability of B multiply by the probability of C. So if I'm going to look at what is the probability of B and C, so let's change our colors. to that one. So the probability of B and C, if we look at B and C, this one and this one is common, and that is 1 in 4. So probability of B and C equals 1 in 4. The probability of B multiplied by the probability of C equals, what is B? We have, this is B, another color, another color. Let's go to blue. So B and C, that's the two that we're going to look at over here. The probability of getting B is 2 in 4 because there's 2 elements, and probability of C, there's 2 elements, so it's also 2 and 4, and that's also equal to a quarter. Okay, so we can say on this side, left-hand side equals right-hand side, therefore they are independent. They are independent. So they can be, there's no common, they can happen at the same time. Okay, the last question, they say use the addition formula to calculate the probability of B or C. And remember, my probability is for B or C is the probability of B multiply by the probability of C. That's a lie. Probability of B plus the probability of C minus the probability of B and C. Okay, so the probability of B, probability of D, we are over here. Probability of B is 2 out of a possible 4. 2 out of 4. Probability of getting C is 2 over 4 minus the probability of B and C. B and C. And we just calculate what was the probability of B and C. Probability of B and C is over here, which is a quarter. So that will give us 2 over 4 plus 2 over 4. So that's a half plus a half is 1. 1 take away a quarter is 3/4. 2 plus 2 is 4. 4 take away 1 is 3 in 4.